Living Room Logic. Okay, everyone, welcome back to another episode of Living Room Logic. We're into season 4 now, which is insane, and we have managed to get the Marai Centre Science Foundation Ireland to sponsor a number of episodes. So we're really grateful to Marai and to Science Foundation Ireland. And for the first episode, we're brought today with Dr. Frances Judge. So, Dr. Judge, thank you so much for coming on the show.
No problem. Nice to be here. I'm actually a lecturer now in environmental engineering in civil engineering in UCC, but I'm also then part of the Offshore Renewables Research Group in Marai down in UCC. So I guess like my research interests are fairly broad ranging. I do things like very early stage development of renewable energy devices, which involves kind of testing in a laboratory, and then also kind of looking ahead into the future, doing things like I suppose looking at scenarios for offshore wind in Ireland and that kind of thing.
And that actually comes in really well with what I would love to talk to you about today, specifically kind of focusing on offshore renewable wind, but we can actually touch on some of the other renewable projects that you've worked on if you're happy to talk about that as well. But my first kind of basic introductory question is, how do wind turbines even work, and what makes offshore wind turbines different to wind turbines on land?
Yeah, so basically they work very simply when wind blows at the blades of a turbine. So the blades, they're kind of like a propeller. It causes them to turn, and in that spinning motion, it spins a generator which creates electricity. So the faster the wind blows, the faster it spins, and the more electricity you get. So it's basically kind of like the opposite to a fan that you might have at home. Those fans, you plug them in, it uses electricity to turn the propeller, which blows air in your face.
So it's like that in backwards. And what makes the offshore ones different?
So they look very similar. So most of your listeners would be very familiar with the ones you see on land. You have a big tall mast with 3 blades attached to the top of it that turns around. So the offshore wind ones, they look very similar to that, but the main difference is the size, really. So the offshore wind ones just tend to be a lot bigger. So in Ireland, I don't know if anyone has been down around Ringaskiddy or down around Cork Harbour, but there's a few very big wind turbines down there. And those ones, they're around 150 metres tall from the base up to the tip of the wings.
Yeah,
so they're pretty big. Yeah, they're very big. And, in particular now, if you're driving somewhere like down to Crosshaven, you see these things kind of looming up over the hillside, and they're really, really enormous. But they're only about half the size of the ones that are currently being built for offshore wind. So the offshore wind ones, the biggest ones that are kind of in production now are about 15 megawatt turbines. So the ones that are going be around the 3 megawatt mark. So the 15 megawatt turbines, they'd be about 300 meters then from the base up to the tip of the wings.
That's insane.
It is insane.
They're huge.
Yeah, they really are huge, because it's actually around, the Eiffel Tower, I think, is something around 300 meters as well. So you're talking about something that size.
God. I didn't realize they were so big, because when you fly over the Irish Sea to go, say, if you're flying, from Ireland to anywhere in Europe, you will see some of these offshore wind sites, and you really don't get a good indication of scale, do you?
You don't, because they're far away. Yeah, you kind of want to be up closer, right, to really appreciate how big they are. Why we kind of build offshore in the first place, and I guess there are a few reasons, but the main reason is that, when you're out at sea, you get much higher and more consistent wind speeds. So the offshore wind farms tend to generate a lot more electricity and at a steadier rate than the wind farms you find on land. And then because building out sea, tends to give you a bit more bang for your buck, then that has led to the development then of the floating wind farms. So basically, when you have a floating wind farm, you have a platform that's mounted on a floating turbine instead of on a foundation that's fixed to the seabed. But with floating platforms, then it means you can build farms even further from shore, where the wind is even better again, and, in places where the water is just too deep to have fixed foundations.
Wow, so there's just entire wind farms that are just floating, completely unattached to the bottom of the ocean?
Well, they're attached by mooring lines basically, but they do,
Okay.
they can move like I mean, they won't go floating off over the horizon.
And so that brings me on to my next question. What are the startings of the offshore wind industry on a kind of global scale? Is the industry relatively new, or has it been ongoing for a while?
Like wind energy has been used by humans for hundreds of years, going right back to the, the Middle Ages when,
That's a
you know,
fantastic point. Yeah.
yeah, when windmills would have been used to like process grain and that kind of thing. But I suppose, through the 20th century, they'd only been kind of one-off ones here and there for various kind of, off-grid projects. So it wasn't
Okay.
really until the 80s that you started to see the first commercial scale wind farms being built on land,
Hmm.
around, places like Europe and in America as well. And but actually the offshore wind followed quite quickly on that because the first offshore wind farm would have been built by the Danes who, tend to be the leaders actually in offshore wind. And
Okay.
that would have been built in the 90s, the early 90s, a wind farm called Vindby in Denmark. So this was a
Hmm.
kind of like a demonstration project and quite small turbines. They were, less than half a megawatt, just a handful of them. But so it was kind of around the early 2000s then that offshore wind farms started to be built kind of on a large scale around Europe, mostly in the North Sea. So the
Hmm.
North Sea, is that body of water between, the east coast of the UK, Norway to the northeast, Denmark and
Yeah.
Germany and Netherlands to the south. So in there, there was an awful lot of offshore wind development happening kind of in the 2000s. Um, but then floating offshore wind, then that is actually very recent because the first floating wind farm wasn't built until 2017, actually. Um, by
Okay.
by the Norwegians, so by Equinor actually, who you might be more familiar with their former name of Statoil, but I think the big
Oh,
oil companies
okay.
don't like to
Wow.
have be associated with the word oil anymore, so they're all rebranding. So anyway,
Okay.
Equinor, built the first floating wind farm off the coast of Scotland back in 2017. And there are a lot of plans for floating offshore wind farms, but there aren't actually that many around the place yet. It's still at quite an early stage. There's one in Portugal and another one in Scotland, and Equinor are in the process at the moment of building another one in the North Sea.
We're really at the start of these floating sites,
We
but
are,
the
yeah,
fixed sites, I'm assuming the opposite is the fixed sites, that they're more common.
they are, yeah, they're a lot more common. They've been
Okay.
around for a while, yeah.
And so that brings me nicely on to my next question about specifically about Ireland. When did this offshore renewable energy kick off in Ireland, and was it difficult to establish it, or was there any backlash, or did people kind of had open arms to this new industry?
Yeah, so actually, surprisingly enough, Ireland, for a very brief period in the early 2000s, we were leaders in the offshore wind industry because
Amazing.
the Arklow Bank wind farm was built back in 2004.
Hmm.
And and at the time, it was actually the first offshore farm in the world to build turbines that were bigger than 3 megawatts. So we were actually,
Okay.
ahead of the curve for a short period of time.
Hmm.
So there's 7 turbines there, and many people would have seen them. But
Yeah, I've seen them.
they,
I think I've seen them myself as
yeah,
well.
you probably have, yeah. So
Mm.
they were actually supposed to be phase one of a much bigger wind farm. So I think it was around 500 megawatts. So a very sizable wind farm, which would have meant,
Wow.
like another 130 turbines in addition to the 7 that were there.
Oh
So that
my
was the
goodness.
plan
Wow.
originally. But subsequent phases of that then were cancelled, and the main reason cited would have been lack of government support. Because I suppose you have to remember at the time that the onshore wind industry was really kind of kicking off in Ireland. The first
Yeah.
commercial wind farm in Ireland on land was built in Mayo in the early 90s. And it was really getting going then in the early 2000s. And, I mean, you can understand as well that like building wind farms on land, there's logistically it's somewhat simpler, than trying to do them out at sea, especially when the
Definitely.
experience isn't really there yet. It's kind of different now because we've had decades of it behind us, but back then,
Yeah.
it was a much smaller ask really to build them on land. So the Arklow Bank, yeah, it never progressed beyond those 7 turbines. Those are our only offshore wind turbines to date. Since then, there have been
Okay.
lots of proposals for offshore wind farms in the Irish Sea, but they've all met with very significant local opposition. They've all been kind of very close to the shore, and you would have had, big objections, from the like of tourist boards.
Mm.
Like some of them, would have been very close to places like Britas Bay and, Bray Head and, you know,
Very popular coastal tourism sites.
exactly, yeah. And I think the plans were kind of made without a whole lot of public consultation as well. And so, people just weren't on board. And, combined with the lack of support then from the government, they just, never really got off the ground. But there was actually another
Okay.
problem as well then, which was actually that up until very recently in Ireland, there was actually no formal planning process for building anything beyond what is called the foreshore. So the foreshore is basically a 12 nautical mile or around 22 kilometer strip of sea between the high water mark, heading out
Yeah.
offshore. So,
Hmm.
and like, if you want to build a large scale offshore wind farm, it really does need to be out beyond that 12 nautical mile limit for it to be accepted.
Wow. So there was no kind of rule book,
Yeah, there was
no
just this
way of.
vacuum, like, yeah, in the planning process, which meant that, like, it was just very difficult to actually, plan to do anything far offshore. So that's only
Mhm.
actually very recently been rectified through new legislation. So hopefully now
Okay,
things should begin
brilliant.
to pick up.
Okay, yeah, because I mean, my next question was going to be asking you about how we're doing in terms of meeting targets, energy targets with the offshore renewable energy, but I guess we're not there yet. We're still working on it.
Yeah, I mean, like, I suppose we haven't missed any targets yet because our main target
Mm,
is for 2030. So it's to have 5 gigawatts of offshore wind deployed by then,
okay.
So, but I mean, yeah, we have a huge way to go because we're starting from this base of just, 25 megawatts. And you're talking about going to, 5,000 megawatts or 5 gigawatts. So,
Wow.
we're starting from a very lowly base. But like,
Hmm.
there has been a huge amount of activity in the sector in the last few years. So there are several very large scale offshore wind farms planned, for the Irish Sea, so off the coasts of Dublin and Louth and Wicklow.
Mm.
And these have been planned for a number of years now. Like, so, work has been ongoing, doing all the surveys and engineering. And this time around, there's been a lot of, public consultation as well. Like, so that should help. And then at the same time, um, there's been a lot of work being done on getting our ports ready to be able to actually, build and support the offshore wind industry. Like,
Mm.
so, places like Rosslare and Cork Harbour as well, and then the ESB are making plans to develop Money Point in the Shannon Estuary as a kind of an offshore wind service hub.
Yeah, of course you need to have the infrastructure on the
You
coast as
do,
well
yeah,
to
you
be able to
do.
service
Yeah,
everything.
and Airgrid have been working hard as well, like, on the kind of the on land side of things too. So like a huge amount of
Hmm.
work is being done, and I suppose now, you know, the political will seems to be there as well. Like, so
Yeah.
while the 5 gigawatts, it is a huge ask, I know I would be hopeful that we would achieve it because everyone is working very hard, to try and get there now at this point.
Yeah, and I would be quite optimistic about it as well. I mean, targets are targets.
Yeah.
They are there to push and to give us momentum. So I can see setting a high target will give the government and everyone the impetus to kind of to push this. You kind of touched on like the legislative difficulties of building these offshore wind sites. But are there like specific difficulties, maybe not to do with the legislation, but like other
Yeah.
logistical issues about building in Irish waters in particular, or are we just met with the same problems that other people are having? Or not problems, more like obstacles.
We have some fairly significant obstacles, all right, that, everyone kind of has to deal with, but we have to deal with on a much bigger scale. And that's
Okay.
because, I suppose you often hear the phrase that Ireland's the potential to be, the Saudi Arabia of offshore wind.
Okay. Well, I've never heard that, so you're telling us and probably a lot of people for the first time. I didn't even know that.
All right, well, that's what some people say. It would be nice if they picked someone other than Saudi Arabia to be our Uh, maybe someone with less human rights abuses like Norway might be a better role model to follow. But,
Yeah,
but
exactly.
anyway, but the reason why they say that is because there is some justification in it in terms of our energy resources. Because
Hmm.
the Northwest Atlantic, it does have the best wind resource of all of Europe, and
Okay.
our territorial waters are huge. They're 7 times our land area, and most of that
Mm.
is the Northwest Atlantic. So we
Hmm.
do have this huge wind resource, but because we have this very big wind resource, the Atlantic also comes with very big waves as well. And then because the seabed falls off very quickly as you get away from the west coast in particular, floating
Yeah.
wind is the only option there really. And one of the problems, with floating wind, is that the platforms obviously can move, so they get knocked around by
Hmm.
the waves. And you really
Yeah.
don't want your platform moving a whole lot when you've got this giant turbine sitting on top of it. Because, if you can imagine,
I
if you're,
absolutely agree.
yeah, I mean, and even if you were down at platform level and your platform is, kicking around a little bit, all those motions are going to be magnified hugely up at the
Yeah.
top of the turbine, up at your hub, like where all your expensive kit is. So
Yeah.
you really don't want it moving a huge amount. So, building platforms that can withstand this Atlantic, wave regime, like, it's a big, it's difficult, like, and as well, it's very expensive. I mean, we will get there for sure, but,
Mm.
it's, there's a reason why they want to build in the Irish Sea first before trying to tackle the Atlantic.
So really, it's a conditions obstacle.
It is.
It's a thing of you're getting. I mean, the whole west coast of Ireland. There's a reason why the weather's worse. We're
Yeah,
getting battered by the northeast Atlantic weather system, and
exactly.
it tends to be a
Exactly.
lot nicer and calmer, and it's shallower in the Irish Sea as well, right? So
Exactly. Yeah. I mean, if you
all of
think
these
about,
nice sheltered,
yeah.
the lovely sheltered Irish Sea sounds a lot better than the big scary North Atlantic.
Yeah, I mean, all our best surf spots are on the, west coast because you've got this vast kind of stretch of Atlantic water where waves can just,
Hmm.
progress uninhibited by obstacles and bash our coasts. Actually, it's one thing building a platform to withstand the conditions as well, but actually there's an even bigger problem then, which is that assuming is that to build an offshore wind farm, you need to use ships. Because what usually happens is that you build your turbine, at your port, let's say Money Point or something in the Shannon Estuary.
Yeah.
You fix it onto your turbine, which is bobbing away at the quayside, and then you get a special towing vessel to tow it out to your site. So that's how they install wind farms. But this kind of towing operation then can only be done if the waves are pretty small.
Oh,
And,
wow.
I mean, you can imagine, if you're towing something that's the size of the Eiffel Tower behind you, obviously you want it to be fairly calm.
It sounds
It
insane.
does sound insane, yeah. And like,
It's amazing.
if it isn't calm, then you've these very expensive specialized towing vessels, standing by for week after week, waiting for the right conditions, to bring your turbine out. And it's, it becomes really
Yeah.
expensive. And that's only to bring one turbine out. So if you have to install a big wind farm, it could take years actually to get all the turbines, out there. And
Just
then,
built.
if you even get them out there, you've another problem then, which is actually, if any of the turbines need maintenance. Because you know, like one thing that, obviously turbines do need regular maintenance. You've got like
Hmm.
gonna have like an annual maintenance schedule, and then if
There's lots
something,
of moving
there's
pieces.
lots of moving pieces exactly, and
Yeah.
chances are something will break at some point, and it'll have to be
Hmm.
replaced. And if you were on a fixed, somewhere nice and fixed in the Irish Sea, where your turbine is fixed to the seabed,
Mm.
you still have problems with weather, but it's much easier to do this because, if you think about it, to do like a fairly minor repair, say, what has to happen is that you need to go out in a boat with a couple of technicians. Those technicians need to hop from the boat onto the turbine, and then they do their few hours work or whatever, and the boat comes back and picks them up.
Yeah.
So if you were to imagine trying to do that, in the Atlantic where, your boat is heaving up and down on, your waves, and then your platform is heaving up and down, and
Yeah.
you're trying to get people from the boat onto the turbine, there's a massive health and safety issue
It
there.
sounds really dangerous.
It
Yeah.
is, yeah,
It's
that's really dangerous. So you could be waiting a long while to get people onto your turbine. And then, like, that's just for, like, a minor regular repair. And if you had something
mhm.
like, if something major went wrong, like say, one of the blades had to be replaced or something, so what happens with a fixed wind farm is that you've got these vessels, they're really cool, called jack-up vessels, which most people probably wouldn't heard of. But jack-up vessels are basically these big ships, and the ships have four big legs on them. So they go out to the wind farm, they get into position, and the four huge legs drops down to hit the
To the
seabed.
seabed.
And then the ship jacks itself up along the legs so that the whole body of the
That's
ship is
crazy.
above the water. And those ships then, they have a big crane on them. So once the ship is jacked up, it's very stable. It's almost like having a crane on dry land. And then you have your
Wow.
turbine is fixed as well. So it's fairly straightforward then to, take off the old blade, and you've brought out your new blade, and you put that back on, and then the ship jacks itself down and off it goes. And that's fine. But obviously, you can't do that for a floating wind farm because the water's too deep.
Your depths are just too great.
Exactly, yeah. So you can't use a jack-up vessel. So you just have a normal vessel, and then you have your floating platform as well. So there's no way you can change a blade, in those conditions. So basically then your only option is to tow it all the way back to your port. And then you have the same issue that you had when you were trying to install it in the first place, which is waiting for the weather to be calm enough to be able to do it.
It's a logistical nightmare.
It is, yeah, it is. And I suppose it means that, like, the turbines are huge, say you have a 15 megawatt turbine. So if one of them breaks, you have 15 megawatts that isn't operating for the length of time it takes to be able to bring it back in and fix it and bring it back out. And, time is money, as they say, like, so the whole time that turbine isn't working, it's costing you, like, so
yeah,
it's, there are a lot of difficulties, really, like.
So what is the maximum depth of those jack ships? What are they called?
Jack-up vessel. Yeah, it's around 60 meters.
Okay, so if you're like in the shelf west of Ireland, it goes off to like 100 or 200 meters, and then it drops to like 5,000. So
yeah, it goes off. It drops off really quick off the south and west coast, like, So yeah, you can't use them. We will be able to use them, all right, in the Irish Sea, but not.
While you were talking about the Eiffel Tower sized 15 gigawatt, did you say 15
15
gigawatt
megawatt turbines?
Megawatt.
Yeah.
What is the sort of price to build one of those?
Kind of depends, there isn't really a sort of a price list on the websites for these kind of things,
Yeah, you can't just go, I would like an Eiffel Tower sized wind turbine, please. No. and add to cart.
No, exactly. Yeah. They're very expensive. And then if you're putting them on the floating platform, like, that platform itself is very, very expensive too, so.
Absolutely. Okay, so we have many obstacles to get through, but offshore oil and all sorts of non-renewable energy companies have bet a lot of these obstacles. So I'm kind of talking about human capacity, and the minds of the world will definitely be able to figure this out at some point.
Definitely,
but you talked about our future situation. It was 5 gigawatts, right?
Yeah.
Is what we want to try and produce
by 2030. Yeah.
By 2030. Okay, so are you quite hopeful that we'll get close in terms of that?
Yeah.
And how much energy is that producing compared to the normal energy system in Ireland from all other sources? Like, is 5 gigawatts a large percentage?
Right now we have around, I think, in the whole island of Ireland, including the north, we have just over 5 gigawatts already just in onshore wind. So
wow.
And that, you see, I suppose wind, like, it's tricky obviously because it doesn't blow all the time, and then when it blows it might blow a lot and it produces more than you can take. And so I think last year maybe wind supplied maybe 30 something % of our total demand. So I suppose, like, we need a lot more to be able to, we need to we need the offshore wind really, because we need that steadier, more predictable wind regime to improve, the
efficiency.
How much renewables, improve the efficiency and how much renewables we can actually take. So the 5 gigawatts will help for sure, but I suppose we kind of have a bigger target beyond that 5 gigawatts, which is to fully decarbonize by 2050. And,
Hmm.
to do that, like, we'll need, like, we have a huge, so there's something like 20 gigawatts of projects that are actually in the pipeline at the moment, at various stages of
Wow.
development. Some of these would be at very early stages.
Hmm.
And the government, recently they identified that actually you could have 30 gigawatts off the west coast alone, of offshore wind. So this is obviously far, this is far in excess of what we could ever use ourselves, directly in terms of electricity generation. But what
Yeah.
you can do with it though is that you can do it to, say, make green hydrogen. So, and if you make green hydrogen, either offshore or onshore, we're basically using renewable electricity. That's a totally clean fuel that you can then use to decarbonize other sectors, like, for instance, heavy transport, or, some heavy industries like steel, steel processing.
My
So
eyes are lighting up. This is making me so happy.
yeah,
This is
yeah, no, like
that's very hopeful.
it's very hopeful, yeah. And I suppose, like, because we have such a huge resource as well, we'd be looking at, producing huge amounts of green hydrogen and sending that off to, mainland Europe as well. Like, and, in that way, so hopefully, if things go the way we hope they will, that, we won't just be meeting our own targets, but, we'll be helping meet EU targets as well. And our offshore wind industry will be really important in that regard.
So not only will it help us meet these carbon net zero goals and our kind of fight against climate change in Ireland, but we could actually make a few bucks as well.
Well, hopefully. I mean, I think that's probably where the Saudi Arabia analogy came into it. Even though, again, I wish they'd do something else.
Yeah,
But yeah,
I kind of like that though, because not everyone in the country is gonna be on board with just saving. I don't know, just meeting. They don't see the need for meeting net zero emissions. Um, so this is another incentive, almost a business incentive, that hey, this isn't just us changing to be cleaner and greener, but we might actually be able to make some money off of this.
yeah. I mean, if we do it right, like, it should be hugely beneficial for the quality of life for everyone living here if we do it properly and we don't
Fantastic.
sell our souls to the big oil companies for them to come in and build and operate all of these, like, so
It needs to be done with a lot of preparation and planning, and
yeah.
with sustainability in mind.
Exactly, and
Um,
just
mm.
transition, and we need to plan carefully.
And so I just want to ask you a little bit about your kind of personal research as well. So where does your research in this realm fit, and where does it fit into this offshore renewable energy industry as a whole?
I kind of have a range of interests, and
Hmm.
like, one of the things that I myself, and then the group that I'm involved in, the Offshore Renewables Group in UCC, is early stage testing of floating wind platforms. So, like, we've been talking about, these huge floating offshore structures that support these giant turbines, but, you don't
Hmm.
just design one of these and then plop it in the water and off you go.
Yeah,
Like,
yeah.
there's you do years and years of testing, and you start, at a very small scale, and you get increasingly bigger, and till you end up with your final
Your
design.
final
And
full scale.
yeah,
Mm.
so in UCC we have this facility down in Ringaskiddy, called the Lear National Ocean Test Facility.
Hmm.
And there's basically a few different wave tanks down there, and there's a whole lot of testing that goes on. So what happens is that, like, a developer of, like, a floating wind platform, they'd build a scale model of their device, so, a much smaller version, of the real thing, basically maybe a 50th the size or something like that. They bring
Yeah.
it down to us, and we put it in one of our wave tanks. And so the wave tank is basically just like a big swimming pool, and at one end there's a wave maker. So a wave maker is just like these big paddles that just move back and forth, and they generate
Hmm.
waves, just send it off down the tank.
Hmm.
So the developers will come along, they'll plonk their device in it, they'll connect it up to a bit of a mooring system to keep it in place, and they might put various sensors or instrumentation on it, and then we send waves at it and see how it performs, basically. So there's a lot of that kind of work that goes on down in Ringaskiddy. And
Can I just say before you go forward that
yeah.
that just sounds so fun?
Yeah, I know, yeah. Well, it can actually be kind of tedious sometimes. It can take forever to get it set up properly, and then it's like it's working, hooray! And it's like, oh, why is it working? I have a PhD student, a very clever fella called Naveed Belvasi, and doing he's doing a very interesting project that basically involves putting lots of these like tiny little particles into the wave tank. And then what he's doing is, once all the tiny particles are in the wave tank, shining a big strong laser at it. So the laser, it illuminates the particles, and then he's got a couple of high resolution cameras set up, and the cameras track the motions of the particles then, which are lit up by the laser. And
wow.
the reason why he's doing this is to try and understand, how the flow and how waves interact with a floating wind platform. And because if we can kind of, improve our understanding of how the water moves around the platform, you have a better understanding of the forces on the platform. So you can do a better job of, fine tuning the design. So like, and the reason why we want to fine tune the design then is, to increase the performance, to make sure that it does what it's supposed to do, while also minimizing the cost, because, a lot of these, they're made out of steel and it's really expensive. So obviously you want to use as little steel as possible. So that's, one of the things now that we'd be doing down below in Ringaskiddy.
So you have one PhD student working on this really cool nitty gritty, the movement of water around these platforms, how it affects them. And so are there any other projects that you kind of are working on that you'd like to talk about?
Yeah. So I have another PhD student, actually, another very intelligent guy called Rahul Ramchandran, and he's looking at towing of these floating platforms. So, I suppose I mentioned previously that, the way a floating wind farm is installed is that you assemble it all on the quayside, and you put it onto your floating platform, your turbine, and then you tow it out. And like up to now, any kind of towing operations like that, they're usually, you plan them, with the captain of the towing vessel that you've hired to do it. And, based on the captain's experience, they come up with a plan of how we do this, and, we use these ropes and we go this time, and these are the wave height limits we need to try and avoid, and whatever. But we're getting to the point now where, the turbines and the platforms are so big that, no one has the experience, because no one's actually done it before. So we need to be able to understand how the platforms move when they're being towed, what are the forces in the towing lines, how the motion of the platform might affect the motion of the vessel. And then, have a look at all these things in different wave conditions to try and build a picture of, what is and just what isn't possible. So in terms of towing, so Rahul is looking at that now. So that should be very interesting as well, and very, important too.
So the output of Rahul's work will really be kind of like a seminal rule book for what can and can't be done in terms of towing these Eiffel Tower sized turbines out to the sea.
Exactly, or at least the start anyway. Maybe not the final rule book, but it'll be the first piece of the puzzle anyway.
In science, everyone's just building, building
incremental
towards
addition of knowledge on top of existing knowledge. Yeah, exactly. I have another project actually, which is probably your listeners might be interested in, and I suppose we were talking earlier about how Ireland, has such a vast renewable resource. That, we're going to produce far more electricity than we need, and even with green hydrogen production as well, we're probably still going to have way too much electricity potentially anyway. So we need to figure out ways to get it from where it's generated to where it's needed. So obviously, the obvious place for it to go would be to like the big cities in mainland Europe. And then as well, we also know that the wind doesn't blow all the time. So if we want to switch completely to renewable energy, then we need a mix of sources, and one of the most important sources is solar energy. So, ideally, we'd be in a position where we'd be getting our renewable energy here in Ireland from solar energy produced in, say, southern Europe during the summer, when maybe there's a big high pressure system over Europe and the wind isn't blowing.
Oh,
But getting energy, from A to B over very long distances is actually really, really difficult. So the way it's done at present is that you've got these huge overhead, high voltage overhead power cables.
mhm,
And, they use up these, vast tracts of land to try and bring cables from, or to bring
absolutely.
energy for electricity over very long distances. So, in places like Europe, land is at a premium, it isn't really ideal to be, building these giant energy transmission corridors.
Overland.
Yeah, exactly. And then obviously overhead power cables don't work out at sea either, and most of our, you know, looking towards 2050, we're going to have a lot of floating offshore wind farms, that are quite far out offshore, maybe, 50 to 100 kilometers off the coast, so
Yeah,
we're going to need some, serious power transmission infrastructure in the seabed,
yeah.
underwater. So one of the solutions then we were looking at is to use superconductors to actually transmit this electricity. So a superconductor is basically a material that, if the conditions are right, it can transmit energy like with practically no losses. So like
Wow.
traditional cables, they're made out of copper, and but superconductors then use materials that they're able to transmit the current with a much higher density. So like to transmit, say, a gigawatt of power using copper cabling, you'd end up with a huge cable, whereas you could do the same thing with a superconductor cable that's, way, way, way smaller. Um,
Okay.
so like the land take, say, would be minuscule in comparison. And then as well, traditional cables, they get very, very hot when they're transmitting energy, so they have to be spaced really far apart. That's why the overhead
Okay.
power lines, they're so wide. You have these huge pylons, with the
Oh,
wires
I
strung
see.
out, because they have to be kept away from each other. Otherwise, there'd be this kind of runaway heating, which would,
Mhm.
the whole thing would fail then. So
It would just start melting. Yeah.
yeah, yeah, pretty much, yeah. So with superconductors, that's not an issue either. So they've a lot of advantages in terms of, like, their how much space they take up. But the tricky
Hmm.
bit then is that to get those conditions where they are superconducting, and to get them in that state, they have to be very, very, very cold. So you're talking about keeping them down below, like, minus 200 degrees Celsius, like, so really, really
Whoa.
cold. So the cables
Okay.
basically have to be housed in these,
Liquid
special
nitrogen or
sleeves
something.
called a cryostat, yeah, and then the cryostat, would be filled with basically the cables would be sitting in like a bed or a pool of liquid nitrogen or something like that to
Do you
keep
know
them
what this
working.
reminds me of? It reminds me of CERN.
Yeah, yeah,
Um,
it's the same technology. Yeah, yeah,
so like
yeah,
I think me and Andrew have talked about this. Andrew's my colleague in the podcast about how they have to supercool the particle accelerator.
yeah.
I'm sure it's probably a lot colder in CERN, but um
Yeah, so in CERN, I think they use liquid, it's either liquid hydrogen or helium. So you're talking about like 20 something Kelvin, which is like minus 250 degrees or something like that.
okay.
Um, but actually, one thing though, it's funny that you mentioned that, because CERN is actually a great example. So they use this special type of superconductor called magnesium diboride. And the reason why they use that one, well, I'm sure there's other reasons, but
Hmm.
it's very cheap to manufacture. So the problem with a lot of superconductors is that there can be quite kind of rare earth metals in them. But this one that they
Yeah.
use in CERN actually is, very readily made. But the problem with it, it has to be cooled down to a much lower temperature than other types, which you can cool with liquid nitrogen. So liquid nitrogen has a boiling point of like, minus 200 degrees or something like that. So
Hmm.
um, they're called high temperature superconductors, which obviously it's still very cold.
It's very relative.
Yeah, but so in CERN they use liquid hydrogen, which is down at, minus 250 or something like that.
Hmm. Hmm.
But there's a kind of a potential great synergy there between that type of technology and offshore wind, because we were talking a lot about using offshore wind to produce green hydrogen. And,
Hmm.
imagine if sometime in the future we could be transmitting, electricity and our green hydrogen. while the green hydrogen is also supercooled and is cooling our superconductors. Imagine if we could do something like that. But this is obviously
it's perfect.
way. I know, it would be great, wouldn't it?
But that's amazing that clearly researchers around the world are already thinking about this, which is also really nice to hear. Yeah. That it's not just, let's just put a load of wind farms out in the middle of nowhere in the ocean and get loads of, and just keep everything else is our traditional cables, our traditional grid and everything. So it's not just the energy production that's being thought about, it's everything, all of the logistics in between as well.
Yeah, I mean, you need to come at this, climate change problem with loads of solutions. There isn't any one solution that's going to do it, so you have to look at wind, and you have to look at solar and wave and maybe nuclear, and then you obviously have to look at your transmission grid, and there's so much work that has to be done around the actual electricity production itself.
Wow. It's such an interesting research area, and I'm sure it's very rewarding to be working in something it's just objectively a good thing. You probably just feel very morally sound, and I think it's amazing work what you and your team are doing.
Thanks. Yeah, it can be quite rewarding at times.
You said it's very rewarding, but of course you have to go into that the wave room and do all of those tedious scale down tests.
Yeah, and it's freezing in there in the winter. So. And if something breaks, you have to get into the tank with a big pair of waders on, and it's so cold. I could last about 5 minutes, and then I have to get out because I get too cold. So
everyone, this is what scientists do for you, okay? To help save the planet. All right, so cut them some slack and give them some support. Dr. Judge, thank you so much for that interview. It's so informative, and a lot of hope from that for the future. So thank you.
Yeah, you're welcome. It was a pleasure to talk to you.
This is the end of the podcast. We hope you enjoyed your time. If you're feeling generous and you're not completely skinned, why don't you give us some of your money? Join our Patreon. Join our Patreon. Join our Patreon.